we have a production function, which we explained before. We have capital per worker on the horizontal axis, and on the vertical axis we have output per worker, and we have this red line, or this red line is the depreciation per worker, which is this delta kt over n. And we have two curves here. So the first one, or the blue one, that shows us the production function or output per worker, and the green one shows us the investment per worker, so which is the second on the right hand side in this expression. So we have output per worker, that is the production function, but also we added the two components here, which again we have this line, the red line explain the depreciation, or to show the depreciation per worker, and the green line shows the investment per worker. So and now we have that point which we denoted as K star over N. Any point before that, when K, or when capital and output are low, investment or saving per worker exceeds depreciation and capital increases. So as we move any point, as we move this dynamic, just think about this before that point. So we're moving toward or across the horizontal axis. So that means we have increases, or because investment is higher than depreciation, so that means capital accumulates and also output per worker increases. But then after that point, so beyond that K star over N, what we have here, we have K and Y, or output and capital, are high, and then investment becomes less than the depreciation rate, and then we move back to this point again, which is that point which we denote as the K star over N. So what does this point, or what is the significance of that point, K star over N here? So this point denote what we call, or what is known as, the steady state. So the steady state in any economy, it's a state in which output per worker and capital per worker are no longer changing. So what you would have here, you have Y star over N is a function of that steady state, where we have capital or K star, which we denoted on this graph as K star over N. So at that point, so again, any point before, it tells us investment is higher than depreciation rate. Any point beyond that, it shows that there's investment is lower or less than depreciation rate, and accordingly capital decreases in the second case. In the first case, when we are before that point, capital accumulates or increase over time. So we move toward that point, but if we are beyond that point, we basically move back to that point again, because capital decreases, and so output per worker, given that we know this relationship between capital, which we show in this slide here. So the steady state value of capital per worker, which is the amount of saving per worker that's sufficient to cover depreciation of the capital stock per worker. So at that point, which we call again, that's the steady state or for any economy. So what is the implication for this? What is the implication of what we said now, of the steady state case we explained? So what we have here, that means the saving rate has no effect on the long run growth of output per worker, and the saving rate determines the level of output per worker in the long run. But then an increase in the saving rate will lead to higher growth, but this is something will happen for some time, but not for forever. And that's exactly what I'm trying to show here. So what we have here, we have a country with a higher saving rate will achieve a higher steady state level of output per worker, and that on the production function in this slide, you would see here moving from S0, the saving rate, to S1, that basically shift up that investment per worker curve, which is the green line here. So we move from that state, from that point, or that curve of investment per worker, where the saving rate is S0, to the second one. So we moved upward, or shift upward, and that means we moved along the production function. So that means we have higher output per worker. Again, we have a higher steady state, a higher steady state level, and that again, that means a higher output per worker. Again, that explains the effect of a country or an economy that has a higher saving rate, and that will achieve a higher steady state level of output per worker, and that's how we show it on that graph. Again, just moving from S0 to S1, that will shift that investment per worker curve upward, and that will result in a higher steady state level of output per worker. So if you take that chunk or that part of the function, you will see that an increase in the saving rate leads to a period of higher growth until output comes to that point where the higher steady state level is. So that's exactly moving along that the production function from point where K0 over N, we move to K1 over N because of a higher saving rate. So in that what the conclusion here, or the main point here, is that an increase in the saving rate will basically lead to a period of higher growth until we go back to the same point, to the steady state, which is now, because we have a higher saving rate, will be a higher steady state level as well. So that means we're moving along that production function, just because we have now a saving rate S1, which is higher than S0. And if that was combined by a change in technology, so in this case, we assume there's no technological progress. So what we see in this slide is an increase in saving rate on output, the effect of an increase in saving rate on output per worker, assuming no technological progress. But if we change that, if there is a technological progress, obviously that will be a bit higher, because again, just learning from what we discussed before, that means a higher level for the production function itself, and giving that an increase in the saving rate leads to, again, a period of growth until we come to that point, or the new level, or the new steady state level. So moving from here, just we should know that what matters to people isn't how many is produced, it's more how much they consume. So basically, that's what matters to people, is not how much we produce or how many is produced. It's more about how much they consume, which government can affect the saving rate by. Obviously, we discussed this before. How much they consume is based on their income, or we looked at the consumption function before. We know that consumption depends on income, and income is split between two components, which is consumption and saving. So saving now, or if you save more, that means you consume less. If you consume more, that means you save less. Okay, because the sum of savings and consumption, that equal income. So basically, governments can change the saving rate if you want to enjoy that period of higher growth until you reach that steady state, or the new steady state point. Then government can change or can affect saving rate through changing public savings. So basically, if you remember, if we go back to what we said about equilibrium, we said that investment equal saving, and saving actually is two component, which is, again, it's private saving plus public saving. Just to make it simple, we assume that public saving is zero, but in reality it doesn't have to be zero. So you don't have to run a balanced budget. You could have deficit, or you could have surplus. So in that case, or to enjoy that, we say, okay, so government can affect saving rate through changing their own savings, or the budget surplus, or having a budget surplus, or run a budget surplus, so where T, or tax revenues, are higher than government spending, or the other way, they can using taxes to affect private saving as well. So again, so you could encourage people to save more. So the golden rule level of capital. So how much capital? That's what we call the golden rule level of capital. So that's basically the level of capital associated with the saving rate that yields the highest level of consumption in steady state. So if you look at this, if we want to plot that, and we have, let's say, the saving rate on the horizontal axis, and on the vertical axis we plot the consumption per worker. So this is basically an increase in the saving rate will lead to an increase so an increase in the saving rate leads to an increase, then a decrease in the steady state. So kind of it goes like a kind of inverted U-shaped relationship. Okay, so basically any point before that SG, that point which would maximize the steady state consumption per worker. So any point before that, or for a saving rate between 0 and that golden rule level, a higher saving rate leads to higher capital per worker and higher output per worker and a higher consumption per worker. But then any point beyond that level, which is again is SG here, or which we denote as the golden rule of level of capital. So we will see a higher saving rate still leads to higher capital per worker and output per worker, but lower consumption per worker, meaning that consumption per worker will move like this, will move up with the saving rate until it comes to that maximum point, and then it falls back again after that if you increase the saving rate above that. So an increase in the saving rate leads to lower consumption for some time, but higher consumption later. And that is the idea. When you save now, you're saving now, aiming to increase your consumption in the future. So far what we explain now, we explain the first component or the first determinant. We try to explain what determines growth. Okay, just before we move to the second point with which we'll conclude this lecture and also conclude the remaining part of this course as well. So again, let's just take that one step back and look at what we are doing now. We are trying to look at the determinants of economic growth. We started with production function. Again, we explained now we left behind now fluctuations in output in the short run. We are looking at what determines the long run or economic growth in the long run. And basically we started with the production function. We tried to understand more about the production function, and we came to this point here where we said, okay, yeah, we said that economic growth will be determined or is determined by two factors here. We'll look at two factors: capital accumulation, which depends on the saving rate, and technological progress, so which we will discuss now. So everything we discussed so far, first we learn about the production function, we explain what we mean by diminishing returns to capital, and then we explain the slope of the production function and how that show the diminishing returns of returns to capital, and then we explain also what would happen when we have technological progress which shift the production function upward, and that's what we will discuss now. So the first half, or so far what we focused on, what we discussed really in detail, is the relationship between output and capital, and how capital accumulation can increase output and output per worker, and how higher saving rate will imply that a higher steady state level, and then that means we will enjoy some sort of a period of economic growth until the economy reach that higher point, which we explained here, with again moving from point k 0 over n, which denote the steady state level associated with S0 saving rate, increasing that S0 saving rate to a higher level, let's say S1 saving rate. That means we'll move along that production function, upward or toward the right, meaning that we would have a higher or a time or a period of growth until we reach that point, which is K1 over N, which denote the new or the higher level of steady state level, the higher steady state level. Moving from here, then we discuss how that will affect consumption, and we discuss that golden rule level of capital. We define that as the level of capital associated with the saving rate that yields the highest level of consumption in steady state. So that's everything we discussed basically so far. So we looked at the first element or the first determinant when we talk about capital accumulation. We explained how that and the bottom line here, or the conclusion here, that a higher saving rate will increase that capital accumulation, will have some growth for some time, so it's temporary, and then until we reach that point, which is the new or the higher new steady state level, and that at that point then that growth will stop. So basically, the conclusion here is that sustained growth requires technological progress, and when saving rates or higher saving rates will lead to a temporary change or temporary growth that's not sustainable. So to have sustainable economic growth, you need improvements in technological progress, and to improve technology or improving technological progress, that will lead to larger quantities of output for any given quantities of K and L, or capital and labor, and also that means better products, new products, a large variety of products. That's what technological progress means.